Welcome to Spring LIB.
The time taken by Earth to make one revolution is 23 hours 56 minutes, which is equivalent to 23.933 hour. We can say that. Okay. Now, the mean radius of the Earth is 3,960 miles, and the linear velocity and acceleration of a point on the surface of the Earth are to be determined. So the first part we are going to determine at the equator. In the next part we are going to determine at Philadelphia, at latitude 40 degree north, and in the third part we are going to measure it at the North Pole. So let's move towards the solution. The time taken by the Earth to make one revolution, that is 23.933 hour, that already we have calculated. Now the angular velocity of Earth can be measured as omega is equal to 2 pi upon t. But as we know, the time period is 23.933 hours. Let's convert this into the second. So we are going to multiply it by 3600, which are the seconds per hour. So our omega will be equivalent to 72.925 into 10 to power minus 6 radian per second. Now, the mean radius of the Earth can be calculated as r is equal to 3,960 mile into 5,280 feet per mile. So, the answer will be 20.91 into 10 to power 6 feet. This is the radius. Now, the radius of the path of the Earth from the figure, from this figure, we can write the formula in the form of r or in the form of radius, that is r is equal to r times cos theta, or you may write cos theta is equal to r over r. That is completely okay. Okay, now moving further, let's calculate this radius at the equator. And we know at the equator the latitude is 0 degree. So in that case, I can write phi will be equivalent to 0 degree. So V will be equivalent to omega times R. Now we have omega also R. So omega is over here. This is the omega, which is 72.925 that we are going to use. 72.925 into 10 to power minus 6 into R is equal to, we are going to use this formula, R cos theta. So the R is 20.91 into cos 0, because as we are having theta is equal to 0. So the answer will be 1525 feet per second. And the acceleration A is equivalent to r dot omega square. So again, by putting all those value, that r is equal to r cos theta, here theta is equal to 0 again, and omega is itself 72.925 into 10 to power minus 6 square. So we will get the answer 0.1112 feet per second square. So this was the first case. Now let's talk about the second case, where at Philadelphia the angle is 40 degree. Okay, So again, V is equal to omega R. Omega is 72.925 into 10 to the power minus 6, and R will be equivalent to R cos theta, where capital R is 20.91 and cos theta will be cos 40. So we will get the answer 1168 feet per second. And acceleration alpha will be equivalent to R dot omega square. So here the difference is only theta is 40 degree. So the answer will be 0.0852 feet per second square. Okay, now let's talk about the last part, where at the north pole angle is 0. So let's make this calculation with 0 angle for the north pole. So in the third case, for the north, angle is 0. So let's calculate first of all R, that is R cos theta. But we know the cos 0 value is 0. So itself the answer will be 0 feet. And so velocity will be also 0 feet per second. And so acceleration will be also 0 feet per second square.